All right, today we're going to look at trigonometric ratios. It's kind of exciting. It does tease a little bit of trig concepts, and we're going to be using ratios as we look at them. Somebody many, many moons ago found some ratios that showed up in right triangles, just like somebody found the Pythagorean theorem, Mr. Pythagorean. He found that relationship of a squared plus b squared equals c squared. And then there's that relationship somebody found with the 30, 60, 90 triangles, kind of exciting. And there's even one with the 45, 45, if you ever want to look into those ones. But there's also one that also shows up with right triangles and the ratios you can use with them. And that's what we're going to investigate today. So our different relationships we have here are different options with trigonometric ratios. We have sine, we have cosine, and we have tangent. And they're abbreviated like this: sine of A, cosine of A, and tangent of A. And those might look familiar. You might have seen those before, and that's what they're referring to. So sine of A, cosine of A, and tangent of A. Well, the definition, or the ratio that plays out, is there is a numerator and a denominator. And the numerator is the measurement, because these are side lengths, so the length of the leg opposite of angle A. Now, all these ratios are basing themselves off of a specific angle. So for instance, if we're looking at sine of A, like right here, we have to go off of angle A. Okay, so these are all dealing off of a specific angle on a right triangle. So let's take a look at this one. So sine of A is looking at the ratio of the length of the leg opposite of A over the length of the leg of the hypotenuse. Okay, and how can we tell these directions? So we got A. Well, the hypotenuse is always going to be there no matter what. It's going to be the longest leg of this right triangle. It's going to be the leg that is opposite, straight across from the right angle. So that hypotenuse is set. The opposite angle is the one that is going to be straight across from the angle in question. And then the adjacent one is, of course, the one right next to. If we were looking at this angle, angle B, this continues to be the hypotenuse, but the opposite angle goes straight across, and the adjacent angle is right next to you. So again, these particular things change depending on what angle you're referring to, what angle you're starting from. And so these are different ratios that are playing out here. So for cosine of A, cosine refers to the length of the adjacent leg over the hypotenuse. It's a little bit different. And the tangent is looking at the ratio of the opposite over adjacent. Okay, and I'm going to tell you a little trick that you can use to kind of help remember all these things, because these ratios are something good to know and to always have. Okay, and you're going to use sine and cosine, tangent, and the ratios to find a couple things. You're going to find the measurement of sides, and you can use it to also find the angles of the right angles. Okay, so we'll be able to try that out. Okay, finding trigonometric ratios. Okay, what are the sine of A, the cosine of A, and the tangent of A. Okay, so A is the one I'm working with, and I can see that this is going to be my hypotenuse, this right here is going to be my opposite, and this right here is going to be my adjacent. So I'm going to keep those handy. Keep an eye on those particular pieces as I'm referring to my ratios. So the sine of A. Now, here's my little thing that I use to remember it. It's pronounced SOHCAHTOA. SOHCAHTOA. Oh yeah, you say it. SOHCAHTOA. This is where I get SOHCAHTOA from. Okay, and it plays out with these particular things. There's my so, and here's my CAH, CAH, and here's my TOA, TOA. So when I'm dealing with trigonometric ratios and I see a right triangle, I start to write something like this. I go so, CAH, let me write a little bigger so we can like see it. I'll do this. I'll go right over here. So, CAH, TOA. And I can see the different ratios that are playing out for each of these, and it allows me to look at each one and use the relationship. So SOHCAHTOA to you and SOHCAHTOA to me. So let's go ahead and find the sine of A. Okay, that is the so. So for sine of A, I need the opposite leg, which is 15 over the hypotenuse, which is 17. And that's the ratio, 15 over 17. The cosine of A is the adjacent leg to angle A, which is 8 over the hypotenuse, which is 17 of the triangle. And the tangent of A is the opposite leg of angle A, which is 15 over the adjacent leg, which is 8. And these are the different ratios that play out. And I can leave them as ratios like that. All right, I would like you to press pause and SOHCAHTOA number 1 on this right triangle. All right, for sine of E, it's in the ratio of 9 over 15, but can be reduced down to 3/5. I did not mention that earlier, but that's what you want to do with these ratios, is simplify them or reduce them. The cosine of E is 4 over 5, and the tangent of E is 3 over 4, all working off of angle E. Now, an exciting thing here, let me see if I got a table up here. All right, so take a look here. You can also utilize your calculator on this one. Now, you're going to be looking for your mode button on your calculator. So on your calculator button, you can hit mode, and it's going to get you to this particular screen. And what you want to do is go down a couple, arrow over to degree, and hit enter, and it'll come back to a clear screen, and then you can use this. This is communicating to your calculator that you want to utilize these trigonometric ratios. So when you type in your calculator, you click a black button called cosine, and you type in 55, and if you hit enter, you will indeed get your number here. And that's what we're looking for. And it gives you a decimal answer, and that is the cosine of 55 degrees. I want you to go ahead and try that. So you grab a calculator, graphing calculator, and you want to make sure you can function in these things, because it's going to help you. Because if you don't, you're going to have to use a table. Your calculator is really handy, because if you didn't have that, you would use a table like this, where you would scroll through and look for your degrees. So we found that the cosine of 55 degrees, so we would look at cosine, and we'd try to find 55 degrees. Cosine of 55 degrees is right there, and if we go back, we see that matches 0.5736 and 0.5736. So if you don't have one of these in your back pocket, you're encouraged to use your graphing calculator. All right, you can use trigonometric ratios to find missing lengths of a right angle. I want you to play around with this a little bit. Let's see, write an equation and solve. So let's look at what we know. Okay, if we're working off of the 48, we know this is my hypotenuse, we know this is the adjacent, and we know this is the opposite. And we're going to use those things to get us our direction. So I'm going to SOHCAHTOA this. So SOHCAHTOA, okay? And I'm going to look, I'm going to see, what do I know? I know opposite and I know hypotenuse. So which one of these have opposite and hypotenuse? And that's going to be my sine. So that tells me I'm going to be using the sine of 48 degrees, and I'm going to be using the ratio of opposite over hypotenuse. So my opposite is x, and my hypotenuse is 14. And now, once I have this, I can start to solve. Next thing I want to do is, in my attempt to solve for x, multiply both by 14, and I end up with the sine of 48 degrees times 14 equals x, which is good. And then when I type in my calculator, again changing it to degree, and do sine of 48, and I multiply that by 14, I end up with about 10.4 is what I end up with. All right, I wanted you to give it a try. I think I give you a chance to do this. Let's see. Yeah, why don't you do this, okay? Press pause, and you get a chance to try to find the length of x using trigonometric ratios. Pause. Okay, I'm going to solve some more here, but I wanted to see if you ended up the right avenue here. I'm going to be working with cosine. I noticed that I've been giving, I'm working with the adjacent side of angle 35 and the hypotenuse of angle 35. So pause again, keep working. All right, let's take a look how you did on this one. Again, I found cosine of 35 degrees equals 1.575 over x. I had to work through it to end up taking and doing 1.575 divided by the cosine of 35 degrees, setting my calculator 2 degrees so I could use that. Now, if you know the lengths of the two sides of a right triangle, you can use the trigonometric ratios to find the angle. So in this particular problem here, we can do such a thing as this. So let's look up here. Now I'm going to SOHCAHTOA so I can see which one I'm doing. So SOHCAHTOA. I do that a lot. I'm going to keep track of it. So what am I trying to find? To measure each angle. Okay, I'm gonna go with angle A first of all here. So if I'm doing angle A, I have the hypotenuse, this is opposite, and this is adjacent. So I have adjacent and a hypotenuse. So I have adjacent and hypotenuse. So I'm gonna work with cosine. So I can see that I have the cosine of angle A is gonna be 12 over 24. So the cosine of A is 0.5. And if I type in my calculator, again, there's a button for this where you're looking for this guy, so cosine. I'm going to look at the other side of it, looking for the angle. I'm going to be finding the measurement of angle A is the cosine of -1 times 0.5. So in my calculator, I'm actually going to hit the button cosine -1, and I'm going to type in 0.5. And I'm going to see that the measurement of angle A is 60 degrees. It uses the table but the opposite direction. So if A is 60 degrees, that means the measurement of angle C has to be 30 degrees. Because 30, 60, 90 gives me my 180 that I'm looking for. Now, do I give you a chance to try this? Ooh, I do. Goody goody. Consider drawing this first, just so you can kind of take a look at everything with the right angle. Now it tells us angle A, it really gives us slight directions. Angle A could be really in either corner, but it doesn't really matter here. So let's see, the opposite of A, so this would be 8, and the hypotenuse is 12, and this is going to be adjacent to it. So we have adjacent, we have opposite, and we have hypotenuse. And if I SOHCAHTOA this, SOHCAHTOA, and yes, I do write it for all of them, I can see that I have the opposite and I have the hypotenuse. So opposite and hypotenuse, I see that I'm going to be using sine. Press pause and see how you do. All right. 41.8 degrees. Hope you got that. Hope you and SOHCAHTOA are becoming good friends. You can use trigonometric ratios to measure some distance indirectly too. To measure such distance is often convenient use as an angle of elevation or an angle of depression. Okay, an angle of elevation is the angle from the horizontal up to a line of sight. An angle of depression is a horizontal down to the line of sight. Okay, and if you look at the graphic there, it's a little bit easier to see what's going on, and we can use that to solve real-world problems. Like for instance, in this situation, we've got ourselves a right triangle plan out here. Let's see, what do I know? I know the height of the ride is 150. I know my angle is 20 degrees, and I'm trying to find if this is the hypotenuse and this is adjacent. I know my adjacent and I know my hypotenuse, so this is a TOA situation. My opposite and my adjacent, this is totally tangent. So I'm going to do my tangent, and I know it's 20 degrees, and my ratio is going to be the 150 over, and it's what I'm trying to find. And let me keep working this out. So I'm going to multiply both sides by x, and so I end up with the tangent 20, x equals 150, divide both sides by the tangent 20, and then end up with x equaling 150 over the tangent of 20. And oh, that's a fun handwriting there, something to brag about. Okay, tangent of 20, and if I typed it in my calculator and I set my calculator to read the degrees, I can see that x equals 412.12 feet. And I think it asks me to rounding. If I round to the 10th, then I'm going to about 410. Yep, round to the nearest 10th foot. So 410 feet about. All right, you're going to do this now too. The elevation changes a little bit, so the ride stays the same at 150. The degree changes a little bit because now you're 50 degrees away, and we're still trying to find out how far you're standing. So it looks like this is still a tangent situation. Why don't you press pause and work it out? So when I work out my tangent ratio, tangent of 50 degrees equals 150 over x. Do my operations here, and I end up with 125.9, so the nearest tenth would be 130 feet away is how far I'm standing away, looking at my friend and waving at them in that fun ride. Oh yeah. You can pause and move on if you would like, unless you would like to go into a situation I like to call the cat cannon situations. This is totally optional, but sometimes you gotta take and bring your trigonometric ratios to life. And so, let's just say you find yourself in a situation where your neighbors they don't move away, they're on vacation, and their cat got out. But you notice that they left their top story, their second story window open, and you want to return the cat home because that's where its food is and its kitty litter and stuff like that. And lucky for you, you own your very own cat cannon. Oh yeah, this is specially designed. It doesn't hurt the cat, but the cat does do some serious meowing. So you load the cat in here, doing its meow. And so let's get our cat loaded. Now, the couple details here is we're going to use some trigonometric ratios. We need to know what angle to put the cannon at. Because if we don't, we send them to a different county, or other stuff happens, which can't be good for cats or sides of buildings. All right, so let's take a look here. So I can see, and I know this, okay? The launch site is, I'm 100 feet away, and I know I need to get it up into the window that's barely open, but, we're crafty like that. And I know that is 220 feet. So if I SOHCAHTOA this guy, SOHCAHTOA, I can see that I have the opposite and I have the adjacent. Opposite and adjacent, that means I'm going to tangent this guy. Okay, so I'm going to do the tangent of tax. I don't want to do tax, I'm going to do tangent. Tax was the other day. So tangent of x, because I don't know what that angle is, but I do know the ratio is 220 over 100. And if I calculate that, the tangent of x is 2.2. And if I go into my calculator and I type the measurement, you're not typing this in, this is just my notation. Okay, now this is where you're going to type in your calculator. You're going to do tangent of -1, and I want to know what the degree of 2.2 is when it's all set. So my calculator will tell me that if I set my cat cannon at 65.6 degrees, it should make it into that window and be all nice and home and safe and happy and all that good stuff. But let's say we run into a situation where I don't know, like my cannon, my cannon is stuck. It's locked in at 48 degrees. But I'm still dealing with the same building, okay? And still got the same building. I got the same cat. Let's see, how tall is that building? What did I say? Oh, 220. Okay, that's not changing. That window hasn't moved since I looked at it last. So it's still 220. And I need to find out my distance here. So how far away do I need to set this cannon so I can get this cute little kitty witty back home in its safety-wafy little home? Let's SOHCAHTOA this, okay? So, S-O-A, C-A-H, TOA, okay? So, S-O-A, yeah, I'm spelling that wrong. There it is, haha. I knew we'd get it. Okay, so what do I know? I know opposite, and I'm looking for adjacent, so opposite and adjacent. Tangent, the winner. Okay, let's tangent this again. Tangent's getting pretty popular. Everybody likes a good tan. Good tan. So the tangent of 48 degrees is going to be my 220 over my x. I am going to multiply both sides by x, and it lands me at tangent of 48x equals 220. I'm going to divide both sides by tangent of 48. Give myself a little room here. And I can see that my x is going to be 220 over the tangent of 48. I'm going to set my calculator so it's in the degree mode, and I'm going to type in 220 divided by, hit the tangent button, and type in 48 and hit equals, and I need to be 198 feet away for this cat to safely arrive home. Oh, that's so cute. All right. Well, I hope you and trigonometric ratios can be friends, like you and the neighbor's cat. See you later.